I'm Chris Foster, Engineering Manager at IRLabs. The German Aerospace Center, commonly known as DLR, is researching atomic oxygen in Earth's upper atmosphere. Atomic oxygen contributes to corrosion and deceleration of satellites in low Earth orbit and is an indicator of climate change. DLR planned to deploy their OSAS-B oxygen spectrometer as part of the Europe's Primera balloon campaign. DLR reached out to us to design the custom Dewar for the OSAS-B, since we have decades of experience with high-altitude cryostats. Many lab systems operate near sea level and at room temperature. The main challenges here were related to operating the upper atmospheric conditions on a balloon gondola. We needed to ensure airtight seals of the vessel during temperature and pressure changes experienced in ascent and descent, meet equipment size and weight budgets of the gondola, withstand impacts during flight and landing, and maintain cold plate temperature and stability during temperature and pressure fluctuations of flight that can interfere with the contact between the liquid cryogens and the cold plate. Our collaborative approach to projects and our customizable solutions allow upgrades and modifications for the best fit for an application like this one. O-rings are used to seal case lids, fill ports, and windows of lab Dewars. But in the upper atmosphere, O-rings can freeze, creating vacuum leaks. So we designed two types of seals: O-ring seals for the DLR team to access in the lab, and indium metal seals that withstand freezing for an airtight seal in high altitude flight. The vessel's size and weight needed to balance a small footprint on the gondola with an increased vessel capacity for extended hold times of more than 24 hours. To keep within size limits, case mass was reduced by designing only the features needed for sensor and equipment mounting. Any unnecessary case material was removed. By reducing flat mounting surfaces on the cylinder, we were able to keep the case slim and reduce unneeded weight. Balloon-mounted instruments are subject to shock during flight and landing. Adding rigid internal supports secured the internal vessel in place to survive impacts. During operation, the temperature and pressure were low enough to freeze liquid nitrogen. This can interfere with the contact to the cold plate, reducing thermal performance. Our teams collaborated through lab testing to determine the best solution to maintain thermal conductivity between solidified nitrogen and the cold plate. After lab testing, it was determined that upgrading the absolute pressure regulators to motorized regulators provided the best control of internal pressure and cold plate temperature. Read more about this project and others on our website and sign up for our company news.